Okay, in today's lesson, first we're going to review over chemical reactions that you should have went over yesterday. Then we're going to talk about types of reactions. So first, chemical reaction is a process of breaking chemical bonds into one or more substances and the reforming of new bonds to create new substances. You know, when you make a peak switch changes, there are physical or chemical changes. So a chemical reaction, another name for that is a chemical change. So new substances are formed from older or from starting substances. The process of making peaks involves some physical changes like chopping vegetables. The process is used by yeast in the dough or by the gas stove to bake the peaks or chemical changes. And if you notice what happens in this reaction, this methane gas reacts with oxygen, and the products of that are carbon dioxide and water. So the evidence chemical reaction, we have a formation of a new gas, so something would bubble or fizz. Formation of a new solid, we said that's what's called, we learned earlier, a precipitate. The release of energy, and which would be like a temperature change, and then a color change. That's how we know if a new substance is being produced. So reactants, products, chemical reactions, you start with reactants that are combined to make products. Your reactants are your starting substances, and the products are the new substances that are produced. So your reactants are always going to be on the left side of the arrow, and your products are always going to be on the right side. So in this reaction, looking back at it, methane CH4 and O2 oxygen gas, they are your reactants. They're on the left side of this arrow, and on the right side of the arrow you have your products, your new substances that are formed, which in this case would be CO2 and H2O. Now sometimes in a reaction you'll see these symbols, and they'll be in parentheses, and they just tell you the phase of each substance in the reaction. S is for solid, L for liquid, G for gas, and AQ is aqueous solution, which means usually dissolved in water because dissolved in solution. So in this case, we have this telling you this liquid water, and it's producing hydrogen gas and oxygen gas. The law of conservation of mass was come up with by Antoine Lavoisier, and he established an important principle based on his experiments with chemical reactions. He said that the total mass of the products of a reaction is equal to the total mass of the reactants. That even holds true for even a burning mass of wood. So your products, your amount of your reactants, matter is not created or destroyed in a chemical reaction, is conserved, so you have the same amount of products. The combined mass for burning wood and oxygen is converted into carbon dioxide and water. So if you would have had 10 grams of this and 10 grams of this, then your products together would add up to 20 grams, the same on each side of the arrow. And also it means you have to have the same number of atoms on each side of the arrow. Lavoisier showed that a closed system must be used when studying chemical reactions. When reactions are closed and are reacted in a closed container, you can show that the mass before and after the reaction is the same. How a chemical reaction is written? When a chemical reaction is written using chemical formulas and symbols, it's called a chemical equation. And that's what this is right here. We use the formulas for the compounds of the substances. Then we use arrows and plus signs to, separate our reactants, separate our products, and so we have numbers and equations. A lot of times, this 2 here is a subscript. It means there's 2 atoms of hydrogen. Since there's no subscript here, that means there's 1 atom oxygen. You got the element symbols. Okay, in chemical equations, the arrow is always included between reactants and products. It means to produce or to yield. So we can say methane gas reacts with oxygen gas to produce carbon dioxide gas and water. In this case, it'd be water vapor. Okay, reactants are always on the left side. Products are always on the right side. Okay, so that should finish up kind of a review from yesterday. And this is the new material. And we're talking about types of chemical reactions. Now there's 5 types. We have a synthesis reaction. It's a reaction in which 2 or more substances combine to make a new substance. Decomposition reaction is a compound breaks down to form 2 or more simpler substances. Single replacement reaction, one element takes the place of another element in a compound. Now, single replacement, it could also be called single displacement. So if you see displacement, it means the same thing. Same thing with double replacement reactions, is ions from 2 compounds change places. That could be double displacement also. And combustion reactions, when a hydrocarbon reacts with oxygen, that's your 2 reactants, and it produces carbon dioxide and water. Those would be your products. So we look at a synthesis reaction. It's when we have 2 or more substances combined to form a new compound. So if you know, in this case, we have sodium reacting with chlorine, and it produces sodium chloride. So you always have 2 reactants, 2 or more reactants, really you could have more than 2, and 1 product, always 1 product. And say Chandler asked Ashley to dance, they're now 1 couple dancing. That's also, you know, Ben Affleck plus Jennifer Lopez. We get Bennifer, 1 couple, 1 product. A decomposition reaction is a reaction where a single compound breaks down into simpler compounds. If you notice here, we got H2CO3, it's hydrogen carbonate, breaks down into water and carbon dioxide. So it's always 1 reactant and 2 or more products. That's how you can tell a decomposition reaction. John's dancing with Kayla. He leaves to get her a drink. They've gone from a dancing couple to 2 single people. So like Tom Cruise and Nicole Kidman, and they decompose, then they are single people, no longer a couple. Okay, single replacement reactions, 1 element replaces another element that is part of a compound. If you notice right here, we have zinc reacting with hydrochloric gas and produces zinc chloride and hydrogen gas. So what happens is this zinc replaces the hydrogen. So 1 element replaces another that's part of a compound, and then you get zinc chloride and hydrogen's left by itself. You can always look at it, the general form of it will be like this. I need to write this down. Element plus compound produces element plus compound. So you have usually 2 reactants to 2 products, and one of them on the left side will be an element, one will be in a compound. On the right side, one will be an element and one will be a compound. It doesn't matter what order they're in, but you can tell it won't be synthesis because synthesis only has 1 product. You can tell it won't be decomposition because decomposition only has 1 reactant. So string replacement, if you have Brad Pitt and Jennifer Aniston plus Angelina Jolie, and then you would end up with Jennifer Aniston by herself and Brad Pitt and Angelina Jolie together. It's 1 replacement going on there. So double replacement reactions is ions from 2 compounds exchange places. So it's kind of a double replacement here. if you notice, sodium chloride reacts with silver fluoride to produce sodium fluoride and silver chloride. So the silver is going over here and reacting with fluorine and forms NaF, and then the sodium reacts with fluorine, and silver reacts with chlorine to form silver chloride. It's a double replacement there. And it's always in this form here. It's always compound plus compound. On the left side is your reactants and produces compound plus compound. Always two reactants, two products, they're all compounds. Okay, double replacement reactions, we have poly D and Snooki, and plus the situation and JUAL. And afterwards you get the situation of Snooki and JUAL and poly E. The double replacement. Now combustion reactions is when a hydrocarbon reacts with oxygen gas to produce carbon dioxide and water. So always, and what a hydrocarbon is something with carbon and hydrogen. It could be, CH4, methane. It could be C2H2. It could be C3H10. It could be C2H5O4. That's still a hydrocarbon. It's got carbon and hydrogen in it. That's what hydrocarbons are. So it reacts with oxygen gas. So oxygen gas is always the other reactant. When we write oxygen gas, it's diatomic, so it's O2. It exists as two atoms combined in a molecule, but that is just one element, the element oxygen. And it produces carbon dioxide and water. Those are always your products. So you have a hydrocarbon, you have oxygen gas as a reactant, and if you look, CO2 and H2O are always your products. So what you should be able to do is look at a reaction based on this information, these 5 different types, and tell me what type of reaction one is. So we look at some examples and we'll classify this reaction. If we look at the first one, we have calcium chloride produces, so there means calcium plus chlorine gas. If you notice, we only have one reactant. When we have one reactant, it's always a decomposition reaction. And I can use D for decomposition. So when you're doing worksheets, you can write just D down if you can remember for that, for decomposition. And then the next example, if we have zinc fluoride plus oxygen gas produces zinc oxide plus fluorine gas. Well, I know it can't be synthesis because synthesis only has one reactant, or one product. Decomposition only has one reactant, and I got two reactants here. So it'll only be one of the others. Well, if I look, I have a compound plus an element, oxygen, and it produces a compound plus an element, and that can only be single replacement. So I can write SR for single replacement. Alright, so the third example, I have C2H8 plus O2 produces CO2 plus H2O. If I notice, I got something with carbon and hydrogen, so I got a hydrocarbon, and then I got oxygen gas as a reactant, CO2 and H2O are my products. Those are always the products of a combustion reaction, so you can just write C for it. Our fourth example, we have magnesium sulfide, MgS, plus iron chloride produces magnesium chloride plus iron sulfide. So you notice we have a compound plus a compound, and then it produces a compound plus a compound. It can be synthesis because it has more than one product. It can't be decomposition, it has more than one reactant. And it can't be single replacement because it's not element plus compound, produces element plus compound. And CO2 and H2O are not my products. So this can only be double replacement, DR. And then my last example, when I have calcium oxide plus oxygen gas, produces calcium, that would be calcium carbonate. So if I look, I have two reactants, I have one product. When I have one product, it's always a synthesis reaction. So I can just put an S, or you can write it out if you would like. So now you should be able to look at the reaction and tell what type it is. So all the future work we do in the next couple of weeks, when we are bouncing equations in a few days, always we're going to classify the reaction also, tell what type it is, and get in the habit of doing that.